Hi everyone. This is another problem that I've had to pre-do, and this is problem number 55 on page 93 of the Siegel book. But also I want to let you know that it might be good practice to also look at page um, page 89 of the Siegel book, where it gives you the example of that. So try and also do this one as well. But 93 is, the one on 93 is also really good. That's just if you don't understand this on the first time. So the problem itself is this. The pKa's of hemoglobin O2 and hemoglobin. This is hemoglobin bound to H and hemoglobin normal. That's what the H is designating. From an aqueous mammal are 6.62 and 8.18 respectively. Calculate the number of moles of H plus taken up by the hemoglobin per mole of O2 released at pH 7.4. So I've had to do this one before, and then because of time constraints, I'm just going to kind of walk you through my calculations. So the first thing I always like to do is I always like to write out what we're starting with, or our roadmap, right? So this is one roadmap, and this is another. And what we're doing is we're releasing 1 mole of O2. So we start off, this is our initial. So we want to figure out so like that, we want to write out where our initial and final are. So this is our initial. We're starting off with this, and then we release 1 mole of this, and it becomes 1 mole of this. And we have to figure out how much H plus was consumed, because now we're converting from this base form into this acid form. And we want to figure out how much of this was converted. And how we're going to do that is we're going to compare either the acid form of this and the acid form of this when we finish, or we can compare the base forms. The cool thing about this is there's 2 ways to do it. So first, what we're going to do is we're going to set up our HH equation. The way I'm diagnosing this is base O2, acid O2, and just normal acid and base. Sorry, acid O2 and base O2, acid and base. This is just to help keep our things separate, but at the same time give us a similar form between both equations. So now we have 7.4 equals 6.62 plus log of this. When we factor this out, we get 6.025 equals base O2. Excuse me. Haven't had my coffee. Acid O2. And then multiply by acid O2. And then we're going to set the similar formula, which we do every time we do a HH, which is 1 equals acid O2 plus base O2. This is again 1 mole, and this is an assumption just to make us easy. If they would have said something like 0.2 millimolar or anything like that, we would have used that number. But this is what we can assume. If they don't tell you, assume 1 moles just to make your life easy. So when we plug this into this base form, we get 7.025 acid O2. Acid O2 equals this amount, which means our base equals this amount. And that's this number is achieved because all we did is we subtracted this from 1. And you should get your base form. Okay. So these are our relative concentrations now of O2. And remember, we want to always double check with our roadmap. So we have a lot more base than acid. Does that make sense? Yes. At pH 7.4 with this pKa, we have a lot more base form than acid. That's what we're predicted. That's why we draw the pH over here. Okay? We're going to do the same exact thing with the other form now. So plug into the HH equation, subtract, raise to the 10 base 10 to this power. Get this. Multiply by acid, you get this. And then we're also assuming 1 mole, again, acid plus base. So when you plug this into the base, you get 1 equals 1.166 acid. And then, so these are the two amounts that you get. So these are in moles. I didn't write that, I apologize. I probably should have. So what I did here is I just rewrote everything from the previous just to kind of go back. And also remember, I want to also predict what we predicted up here. For this amount is we're predicting more acid than base. And that makes sense because that's what we're getting. We're getting more acid than base. So now what we need to do is we need to know that, figure out is once we converted 1 mole of this to 1 mole of this, how much H was consumed. So that means what is the difference between this form and this form? Or you can do what is the difference between this form and this form, and that's going to tell you how much H was consumed. Is this difference will tell you how many moles of H is consumed. And that's pretty much all we do, and we get H plus per 1 mole of O2 because we assumed 1 mole. So when 1 mole of this converts into this form, our ratio of our acid to our base shifts over to this way, and it consumes H plus, and it makes this amount difference. If I went too fast on the HH equations, I have a lot more videos up. You guys should be pretty comfortable with that speed. So you guys can refer to any other videos if I went a little too fast for you. The main things about this is just figuring out what your initial and your final are. Your initial is this. Your initial is this. Your final is this. Stuff like that. Again, refer to page 89 in the Siegel book, and it can give you another example of this if you're still stuck, or if you feel like you don't fully grasp it. Also, I haven't really heard too many quantitative problems from a lot of people. And that's why I haven't done any of these. So if you guys have any problems with any quantitative things, you guys can either post on here and I'll do a video, or you can send me an email. But if you comment on here, then I'll get an email anyway. So yep, let me know if there's any problems I can do for you, and I hope this helped out.